Hello, and welcome to my presentation. Today, I'll be talking about the neuromuscular junction. Here is a skeletal muscle. Skeletal muscles are our voluntary muscles that attach by tendons to our bones and enable us to move and perform daily activities such as running, chewing, and writing, or pretty much anything. The skeletal muscle is made up of bundles of fascicles, and the fascicles are made up of muscle fibers. This is where the motor neurons come in to form the neuromuscular junction. The neuromuscular junction refers to the connection between a motor neuron and a muscle fiber, which is a chemical synapse between the nerve terminal and a specialized area called the motor end plate. When an action potential travels down the axon and reaches the axon terminal, it causes a release of the neurotransmitter acetylcholine into the synaptic space. The acetylcholine binds to nicotinic receptors on the end plate. These receptors are ligand-gated ion channels, which means that they can only open when binding to a chemical messenger, such as a neurotransmitter like acetylcholine. When the acetylcholine binds to these receptors, they open to allow sodium to enter the cell, which depolarizes the cell membrane and produces the end plate potential. If the muscle reaches the threshold required to activate voltage-gated sodium channels located outside the end plate, then an action potential will occur in the muscle. When activated, these channels allow faster influx of sodium, further depolarizing and eventually reversing the polarity of the cell membrane. After these channels close, voltage-gated potassium channels open for potassium to move out, which quickly returns membrane voltage to its original resting value. Once generated, the action potential initiates a wave of depolarization that travels over the cell membrane. The depolarization of the muscle depolarizes the T-tubule membrane, which carries the depolarization current deep into the muscle fiber and reaches the sarcoplasmic reticulum. Here, it activates voltage-gated calcium channels, releasing calcium from the sarcoplasmic reticulum into the cytosol of the muscle cells, which finally prompts the muscle contraction. After the muscle contracts, an important enzyme called acetylcholinesterase breaks down the remaining acetylcholine, ending the synaptic activation and giving the muscle time to relax. So, this is the process that happens when the neuromuscular junction functions correctly. But what happens when one of the steps of the neuromuscular junction isn't functioning properly? One example is myasthenia gravis, an autoimmune disorder and common neuromuscular disease that produces antibodies that block or damage the nicotinic acetylcholine receptors at the neuromuscular junction. This disease produces varying degrees of muscle weakness and is generally treated with medications that inhibit acetylcholinesterase. Another example is amyotrophic lateral sclerosis, also known as ALS. ALS causes the motor neurons to gradually deteriorate and then die. Since there is a lack of functioning motor neurons, the neuromuscular junction cannot occur and neither can a muscle contraction. Activity at the neuromuscular junction is essential for the contraction of skeletal muscle to occur, and even just to keep muscles from atrophying. Thank you for watching. Bye.